Okay, so in this next question, we're asked to use the vertical line test to determine whether or not y is a function of x. And we're given three different graphs here to determine whether or not they're functions. And the important thing to remember here is what the vertical line test is. It says if you have any graph, so I'll just draw like a sine graph, for example, right here. If you have any graph and it's like this, right, these are your x and y axes. If I draw a vertical line at any point and it only intersects with the graph at one point, then it is a function. If it intersects at more than one point, then it is not a function. And if you think about it, that's basically just saying, does each input have only one output? It's just the definition of what a function is. Because when I pick a vertical line, I'm picking an x value, I'm picking an input, and if it intersects the graph only once, meaning if it has only one output, then it is a function. And if it has if it intersects the graph more than once, then of course it's not a function. So in this parabola right here, you can see that no matter how many vertical lines I draw here, each vertical line only intersects with the graph at one point. It doesn't intersect with it more than once. So this right here is a function. This first graph is a function. Now I have this graph here which looks like a parabola on its side, and you can see that when I draw a vertical line, it intersects twice. It intersects here, and it intersects here. At any vertical line I draw, it will intersect twice. So this is not a function. This one, it may look like it's not a function because of this part right here. You might be thinking that, well, it looks like a vertical line hits it right here. You have to remember that this point is an asymptote. These two lines will never be on this y-axis line. And because of that, if I'm drawing a vertical line like this, it will only touch one point on this graph, and then I won't be able to plug in anything at x equals 0. So then I immediately have to jump to the right of the y-axis line, and again I see that it only crosses at one point. So this is a function. Okay, so in this next question we're asked to find the zeros of the function algebraically, and the function we're given is f of x equals 2x squared minus 7x minus 30. So the important thing to remember here is what it means to find the zeros. It wants you to find the x values where f of x equals 0. And in order to find this, I can just plug in 0 for f of x. So I have 0 equals 2x squared minus 7x minus 30. And now we have a quadratic equation here, albeit not so friendly looking quadratic. It's 2x squared minus 7x minus 30. I don't see anything I can factor it out into very easily, so I'm going to stick with the quadratic formula. And if you don't remember the quadratic formula, it's something you're going to want to remember, something you're going to want to memorize. It's negative b plus or minus the square root of b squared minus 4ac, and that whole thing is over 2a. And by finding this, we will essentially find our answer, because that's basically like if we factored it out and set it equal to 0. I'm explaining this really wrong. Hold on, let me start over. So when we do the quadratic formula, we're saying x equals that, and at that value f of x equals 0. So if we do the quadratic formula, we should find the zeros of the function. I hope that makes a little bit more sense. So I'm going to do negative b, so that's going to be, it's not negative b, it's really the opposite of b. So the opposite of the opposite of negative 7 is 7. Then we have plus or minus the square root of negative 7 squared minus 4 times 2 times negative 30. And this is all going to be over 2 times 2. And if you're wondering where I got these numbers from, this 2 is A, this negative 7 is B, and this negative 30 is C. So that will give us, if we evaluate the different things going on here, we have 49, because that's negative 7 squared. 49 minus 8 times negative 30 over 4. And then that's going to be, if we evaluate the multiplication going on here, that's going to be 7 plus or minus the square root of 49 plus 240 over 4, which is 7 plus or minus the square root of 289 over 4. The square root of 289 is 17, so we have 2 plus or minus 7, we have 7 plus or minus this 17 over 4. Now we have to evaluate each individual plus and minuses. So 7 plus 17 over 4 is 24 over 4, which is 6. Meaning, if we were to plug 6 in for x, we'd get 0 here. And then 7 minus 17 over 4. That's negative 10 over 4, which if we divide both the numerator and the denominator by 2, we'll find that it's negative 5 over 2. So if we plug negative 5 over 2 or 6 in for x, then we'll get f of x equals 0. Okay, so in this next question, we're asked to find the zeros of the function algebraically, and the function we're given is f of x equals 3x squared plus 22x minus 16. So again, we're going to set this equal to 0. So we have 0 equals 3x squared plus 22x minus 16. And now we have another quadratic equation here. But instead of using the quadratic formula, because that can be time consuming or you might not remember all the negative b plus or minus the square root of all that, I'm going to show you a way that might be easier for you. It's called factoring by grouping. Basically, you're going to multiply this first number by the last number. So you have 3 times negative 16 is negative 48. And you're going to ask yourself, what two numbers multiply to give me negative 48 and add to give me 22? And you're going to find that it's negative 2 and 24. Negative 2 times 24 is negative 48, and negative 2 plus 24 is 22. So then with that information, I'm going to rewrite this as 3x squared plus 24x minus 2x, other way around, 3x squared minus 2x plus 24x minus 16. Now when I factor by grouping, I basically am going to group these two terms together and these two terms together. So I'm going to have 3x squared minus 2x plus 24x minus 16. And here, and in this first term, I can factor out an x. So I'm going to have x times 3x minus 2. And then here I can factor out an 8. So I'm going to have 8 times 3x minus 2. Because if we distribute the 8 to the 3x and the negative 2, we'd get 24x minus 16. Now I'm going to combine the x and the 8 into one expression, and this 3x minus 2, I'm just going to combine it basically into one 3x minus 2, and that I'll explain what I did once I write it out fully. So it's going to be x plus 8 times 3x minus 2 equals 0. And if this step is a little bit confusing, if you're wondering why there's only one 3x minus 2 and why it's not 3x minus 2 squared, think about it like this. I essentially distributed this whole 3x minus 2. Like, let's say I say a equals 3x minus 2. Just for example, I distributed that to the x and the plus 8, so I would have x times a plus 8a. And then if I rewrite what a actually is, that's x times 3x minus 2 plus 8 times 3x minus 2, which is exactly what we have up here. So now we have it equal to 0, and we can do x plus 8 equals 0, subtract the 8, x equals negative 8, and then 3x minus 2 equals 0, add 2, 3x equals 2, divide by 3, and x equals 2/3. So those are the zeros of this function. Okay, so in this next question we're asked to do the exact same thing, but this time our function is x over 9x squared minus 4, and 9x squared minus 4 is in the denominator. So I'm going to rewrite this as 0 equals x over 9x squared minus 4. And now you might be thinking to yourself that you're going to want to start by factoring this out into what would it be? It'd be 3x plus 2 and 3x minus 2. You might be thinking about starting there, but even that, you don't even need to do that much. Let me just rewrite this really quickly. Because we have an x in the numerator, I can just multiply this by 9x squared minus 4, so that these cancel out, and then I multiply this by 9x squared minus 4. 9x squared minus 4 times 0 is 0, and we have 0 times x, and that's your final answer. Much easier than doing anything with 3x squared plus or minus 2, or 3x plus or minus 2. Okay, so in this next question we're given the exact same instructions, except now they want us to do it with f of x equals 1/2 x cubed minus x. So once again I'm going to rewrite this as 1/2, 0 equals 1/2 x cubed minus x. And now what I can do is I can factor out a 0. I can factor out an x, I mean. So I'm going to have x times 1/2 x squared minus 1. So now I can set each of these equal to 0. So I'm going to have x equals 0, and then I'm going to have 1/2 x squared minus 1 equal to 0. I'm going to add 1 to both sides, so I have 1/2 x squared equals 1. Then I'm going to divide by 1/2, and dividing by 1/2 is going to be the same thing as multiplying by 2. So x squared equals 2. Then I'm going to take the square root. I'm going to have x equals plus or minus the square root of 2. And the square root of 2 is not it's a decimal number, so you don't have to simplify it. You can just write it as the square root of 2. But make sure that it's a plus or minus. Okay, so in this next question, we're once again asked to find the zeros of the function algebraically, but this time our function is f of x equals 4x cubed minus 24x squared minus x plus 6. So once again, I'm going to start off by factoring this via grouping. So I'm going to make two groups here. My first group is going to consist of 4x cubed minus 24x squared, and then my second group is going to be negative x plus 6. So what I'm going to have is 4x cubed minus 24x squared plus negative x plus 6. And this is going to be equal to 0, because when they say find the zeros of the function, they want where f of x equals 0. So I just kind of moved f of x over to the right side of the equation and just made it 0. So in 4x cubed minus 24x squared, I can factor out a 4x squared. I can actually factor out a negative 4x squared. And that's going to leave me with negative x plus 6. Because if we distribute the negative 4x squared, we're going to get positive 4x cubed minus 24x squared. And then we're just going to have that negative x plus 6 equals 0. Now from here, I can kind of take my groupings and condense them. So I'll have negative 4x squared plus 1. And that 1 is coming from, there's really a hidden 1 right here. Because if you distribute the 1 to the negative x and 6, you're just going to have negative x and 6 still. It's the same thing. But for factoring purposes, it's basically a 1. It's technically a 1. So it's negative 4x squared plus 1 times negative x plus 6 equals 0. Now from here, I can set each of these terms individually equal to 0. So I'll have negative 4x squared plus 1 equals 0. I'll subtract the 1. And I'll have negative 4x squared equals negative 1. Then I'll divide by negative 4 equals positive 1/4, because we're dividing with two negatives. And then I'm going to take the square root. And remember, when you take the square root of a fraction, it's like taking the square root of the numerator and the denominator. So it's the square root of 1 over the square root of 4, which is 1/2. But because we're taking the square root, it's plus or minus. So x equals plus or minus 1/2 is one of our zeros, and we also have this one over here. Negative x plus 6 equals 0. I can subtract by 6 on both sides, and I'll have negative x equals negative 6. And then because I'm trying to get x completely by itself, I want to get rid of that negative, so I'm going to divide by negative 1, and negative 6 divided by negative 1 is positive 6. So we have 3 zeros in this problem, plus or minus 1/2 and 6. Okay, so in this next problem, we're once again asked to find the zeros of the function algebraically, and this time our function is f of x equals the square root of 2x minus 1, but only the 2x is underneath the square root. The minus 1 is out of the square root. So once again, I'm going to replace f of x with 0. So I have 0 equals the square root of 2x minus 1. I'm going to add 1 to both sides, and now I have 1 equals the square root of 2x. Now in order to get rid of the square root, I'm going to have to square. So I'm going to raise square root of 2x to the second power. I'm going to square it, and I'm going to square 1 as well. 1 squared is 1, and the square root of 2x squared, the square root and the squared cancel out, and I have 2x. Then I divide by 1, or I divide by 2, I'm sorry. Divide by 2, and I have my 0 at x equals 1/2. And that's your answer for that one. Okay, so in this next question we're asked to determine whether the intervals, or determine the intervals over which the function is increasing, decreasing, and constant. And we're given this linear function right here. And in later courses like calculus, you're going to learn a much easier way to determine whether a function is increasing, decreasing, or constant. But unfortunately, we're asked to this function is increasing if I pick like an x1 point over here and an x2 point over here. If f of x1 is less than f of x2, then that function is increasing over that interval. So if I pick this x1 point, the f of x point is going to be over here. This is going to be my f of x1. And this point over here is going to be my f of x2. Well, we can see that f of x2 is higher on the y-axis than f of x1, so f of x2 is greater than f of x1, which means that we know for a fact that the function is increasing at least over this interval, whatever we picked here. It looks like I picked something like -2 to 1. So we know that it's increasing for sure over that interval. But we can see that this is a linear function. It doesn't change. This will hold true at any point. At any x1 and x2 point, greater than f of x1. So this is increasing on the interval -∞, or I guess I should write that it's increasing. I'm going to simplify, or I'm going to abbreviate increasing as just I and C, and I'm going to say that it's increasing on -∞ to infinity. There is never a spot on this graph where f of x2 is less than f of x1. Okay, so in this next question we're once again asked to determine the intervals over which the function is increasing, decreasing, or constant. But now we seem to have what looks like some sort of cubic function here. So let's start with looking for increasing intervals first. So I'm going to be looking where f of x2 is greater than f of x1. So if I pick a point right here, for example, and I pick this point right here that it gives me, 0, 2, it's just an easy, nice point that it gives me, I can see that f of x1 is way down here, but f of x2 is way up here. So it's increasing over this interval, and we can see that at this other point it gives me, and I'll write DEC for decreasing. Then we have from 0 to 2 and 2 to negative 2, well, I can see that if I call my f of x, if I call my f of 0 x1, or f of x1, I'm making this really confusing. If I call this point f of x1 now, and now this is my f of x2, because I'm examining more of the graph, if I do that, I can see that now my f of x2 is less than my f of x1. That means it's decreasing. If f of x2 is less than your f of x1, that means it's decreasing. Now I go from my 2, negative 2 point. Now if I call that f of x1, I call this point way up here f of x2, I can see that this f of x2 is greater than my f of x1, so it's increasing again here. So again, it's increasing, decreasing, increasing. So what intervals are those? Well, it's increasing from negative infinity to 0. Union. This union is like a long U, like it looks like this. It just means and. Union 2 to infinity. Like this. Then it's decreasing from 0 to 2. And that would be your answer for this one. Okay, so once again, exact same instructions, but a very different graph now. So once again, they give us 2 points. They give us negative 1, comma 2, and 1, comma 2. I'm going to go to this farthest right interval over here, or this farthest right point, I guess, and call that f of x1. And then this will be my f of x2 right here. And I can see that f of x2, if I draw the line over to where that f of x2 point would be right here, or that f of x2 value, well, we know it's 2 because they give us that. So this is 2, and this is somewhere above 6. So my f of x2 is less than my f of x1. So it's actually decreasing on this interval. Then right here, if I go here, I can see that both the y values, otherwise known as the f of x values, are the same. When f of x1 equals f of x2, the graph is constant over that interval. So over this interval, they're constant. They're equal to each other. Now at this point, 1, comma 2, if I call that my f of x1, if I call 1, comma 2 my f of x1, and this point on the farthest, on the rightmost part of the graph, f of x2, f of x2, I can see that this f of x2 is greater than my f of x1. It's increasing on this interval. So when I go to write my final answer, I'm going to write increasing on 1 to infinity, decreasing on negative infinity to negative 1, and constant, which I'm going to abbreviate as CON, on negative 1 to 1. So this would be your answers for that one.